is the taste of the sweet life.
So Alex baseball helmet is thrown over with an initial velocity of 90 feet over second from a 700 feet high building. And in letter A, we have to write the position equation for the baseball helmet. So here we need to find the equation of side of time. So because with this formula we can find the time at any given position. So we need to substitute the original formula. And we have 60 here because in gravity in feet it's 32, but in the formula we need to divide it by 2. So we divide 32 by 2 and we get 60.
Okay, so first of all, we need to use again the equation that we got in question 8. And to that, we need to use the derivative definition. So the derivative definition is S of t plus delta t. And everywhere where we see a t, in here and in here, we need to put this t plus delta t. See, here's a t, and it was substituted by t plus delta t. T squared is t delta t to the square. So we solve that, and we have this answer, and this is a perfect square trinomial. And then we need to subtract this from this. So we subtract everything, we eliminate everything we have to eliminate, and in the end we're left with this equation. So then, to simplify this, we get out the common factor. In this case, the common factor is delta t. So we are left with 90 minus 32t, and in this case, our delta t plus squared. So we are left with just minus 16 delta t. And then we just get that equation, but now we need to use the limit. We need to know what is happening when delta t is approaching 0. The limit of delta t approaching 0 of the function. We cannot simplify anything anymore in here, so we just substitute, and this is our final answer. S of t is equal to 90 minus 32t.
So the change velocity is the velocity that the helmet has at any time. So we get the answer of the previous exercise and we make it equal to 0. So we have to isolate t. And we'll turn to phone in 1 second. So we get the time and we substitute it in the first equation, which was like this, the first one. And we solve it and we obtain this result.
I have a question, well, a doubt. I've been making my calculations and I think that the same result we can obtain it using physics. Is that true?
That's correct. We can use physics. We use this formula and we isolate y. Then we substitute the values and we obtain the same result.
Okay, so what we need to do is to take our previous equation and we need to equal everything to 0 and we need to change the sign to everything. And in order to simplify this or to solve this, we need to use the quadratic equation. Okay, so our quadratic equation is until we get an answer. Okay, so now this answer, we need to substitute it in the previous formula. Remember we had the formula, it was S of t equals 90 minus 32t. Okay, so we need to substitute this 10 in here. So we put it in here also. So it's 10 and we just solve it. Minus 230 feet over second. So minus 230 feet over second is the value of the impact velocity for the baseball helmet.
So we use this formula, which is acceleration equals final velocity minus initial velocity over time. We substitute with the ones we had in the previous exercise, and we solve. so we get minus 33 over 6. Also, we have to remember that the acceleration is always constant.
Question, they have to decide if the baseball helmet can still be in one piece after hitting the ground. So we have this information. A baseball helmet receives the impact of a baseball at 160.93 kilometers per hour approximately. So we have our impact velocity that is 230 feet over seconds, and we have to convert that into kilometers per hour. So we solve the problem, and we get 252 kilometers per hour, and that is our velocity at the impact. And because this is a greater number than this, it obviously breaks into